Hello, in this video I will show you about matrix. So in this video I'm not going to show you how to solve it, but it is more about definition and the types of it, because we need to know about them before we be able to solve it. Okay, so first, what is matrix? Obviously not this one. Alright, so it is an array of number that are arranged in rows and columns. Matrix usually written as m by n, where m is number of rows and n is number of columns. Matrix is also usually denoted by capital letters such as A, B, C, and so on. Example: matrix A is a 2 by 3 matrix. The above matrix has 2 rows and 3 columns. Okay, you can see 2 rows right over here. This is row and this is columns. So the above matrix has 2 rows and 3 columns. It is called 2 by 3 matrix. Order of the matrix equals number of rows times with number of columns. So you get 2 by 3. So type of matrix: diagonal matrix, null matrix, identity matrix, triangular matrix, and symmetrical matrix. Okay, diagonal matrix. Before that, quick note over here. Square matrix means that both rows and column has the same number. Example: 2 by 2, 3 by 3, 4 by 4, and etc. So what is diagonal matrix? A square matrix is called diagonal matrix if all elements except those in the principal diagonal are 0. Okay, example: matrix A. Okay, you can see right here the only diagonal is 1, 2, 3. So other than that they will become 0, like this. Okay, like this. So 1, 2, 3 is diagonal and the others will be 0. That is diagonal matrix. Matrix. A symmetric matrix is a square that satisfies A dash equal to A, where A dash denotes, A transpose denotes the transpose. So Aij equals Aji. This also implies A inverse times with A transpose equals to I, where I is the identity matrix. For example, okay, matrix A has 1 and 2, which is 2 row and 1 column. So if you try to convert it into A transpose, it will become like this. So these two is very different, not very similar. Okay, so it is not equal, because this has 2 row and 1 column, while this one has 1 row and 2 columns. Same goes as for B. For B, they have 3 rows and 2 columns. However, for the B transpose, it will become 2 rows and 3 columns. So this 2 is completely different. Alright. However, if you see for the C matrix and D matrix, they have the same number of row and columns. So it just simply, you can say the symmetrical matrix is same thing with square matrix, because they have the same number of row and columns. Okay, look at this. C has 2 by 2 and D has 3 by 3. The other one is identity matrix, a square matrix in which every diagonal element and non-diagonal element is 0. It is denoted by I. Okay, it is height over here. So if you can see right here, So it is simply like this, the diagonal matrix, but right now it's just number 1 and 0. Okay, every diagonal will become 1 and the others will be 0. Okay, if you try to solve it, okay, like this is normal matrix, and you try to times with this identity matrix, you will get the same answer with this matrix. Okay, no matter how hard you try, you still will get the same one. All right, move on. Null matrix. Okay, this one is weird. A matrix in which every element is 0. It's just completely 0. Right over here, 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 here. So it just 0. So yeah, it's just 0. I don't have any explanation for this one. So the last one, triangular matrix. So it will be divided by 2, which is upper triangular matrix and lower triangular matrix. Okay, so for the upper triangular matrix, definition is a square matrix in which all entries below the main diagonal are 0. Okay, you see right here, this one 3621 is the diagonal, and the upper one is still right here. It not convert to 0. However, for the 0 one, for the lower one, below the diagonal, it becomes 0. This is the upper triangular matrix. As for lower triangular matrix, is opposite of it. Okay, a square matrix in which all entries above the main diagonal are 0. They just switch the sign. Okay, switch the sign. Okay, so this right here, diagonal, you can see. Let me zoom. Oh my god, let me zoom it first. So this one is diagonal, and this one is a lower or the below one, below diagonal, and this is upper diagonal, becomes 0. So this one is goes to lower triangular because the lower one still um, still have the number. Okay, that's all for me. Thank you.